research is concerned with decarbonisation of road freight, which is 7 to 8% of world carbon emissions. It's one of those difficult to abate sectors which is increasing. I lead the Centre for Sustainable Road Freight, which is an ecosystem of academics and industry and policymakers. The big issues are, at the moment, electrification of heavy vehicles, and that's an interesting combination of logistics and engineering, the energy system, all mixed together, and so it makes it a very challenging multidisciplinary problem. The research covers a very wide area. We look at everything through the 3 Ps of sustainability: people, planet, profit. So we're trying to develop solutions to decarbonise road freight for the planet. We have to, those solutions need to be economically viable, otherwise they won't fly, and they have to be socially and politically acceptable. Time is of the essence, and the companies that we work with are very keen to decarbonise their operations, their freight operations quickly, to meet their internal ESG goals, and obviously to be decarbonised by 2050. So we help them with short-term solutions, but we're also interested in the transition. How do we transition the entire industry, and not just in the UK but all around the world? How do we transition that industry to decarbonise by 2050? We also are interested in different scales, from small to very large. So at the one end, we're interested in aerodynamic flows around particular parts of vehicles. At the other, in the logistics of the entire country and the world. How do you place warehouses around the country to minimise the carbon footprint of supply chains? Those kinds of questions. The research is very multidisciplinary in nature and involves engineering and logistics and policy and energy, all of which are topics that are important around the university. We are the only group in the world that combines all these things. We've set up 3 sister centres that are parallel to the Centre for Sustainable Road Freight. One in India, one in China, and one in South Africa. And these are separate centres that are autonomous, that we don't run them, but we work and collaborate with them. We've set them up in our same mould, so they also have engineering and logistics and policy, and they also have industrial partners in those 3 areas. So we've got these 4 centres around the world, all collaborating. We share tools and software and staff exchanges and so on. We work on joint projects together. And the idea really is to all work together to try to translate the best of what we've learnt about decarbonising road freight to the places in the world where the biggest emissions are happening. That international activity, that international outreach brings great students and staff and very good international aspect to sustainability research in the university. Urban vehicles are already transitioning to electric, and we'll see within the next 10 years that they'll all be electric. We'll wonder why on earth we drove diesel trucks in cities. But the long haul is much more difficult. Batteries are heavy and they need to be charged. And for road freight systems, they need to be charged within the logistics day and within the logistics task, so that they don't add time and cost to logistics. So that adds quite a lot of challenge, and it means that the topic is all about charging. It's really not about the vehicles, it's about the charging infrastructure. And so we're doing a lot of work on that. It's an interesting problem because it involves the technology, of course, it involves logistics, it involves the energy and energy supply, and it involves policy as well. So we've got all of these problems, all of these fields of activity coming together in this same problem, and they all have to be solved together. we're spinning out little pieces of research all the time. An interesting example is some aerodynamics work we did specifically for John Lewis, Waitrose. If you drive around the countryside, you'll see Waitrose vehicles with aerodynamics that are designed as a result of the work we did here in the engineering department. That particular aerodynamic treatment saves Waitrose about 7% of their fuel on the highway, so it's pretty good. We're working with a company called Turner's in Newmarket, and they're a so-called third-party logistics company, and we've been working with them on driving strategies for eco-driving. And we've developed a little app, phone app, which talks to the driver and instructs the driver as they're driving along. And that one, we're still waiting for the final numbers. It looks like we'll be able to save upwards of 10% of fuel by doing that. Now, if you think about that from the point of view of a company, each one of their vehicles spends about £50,000 a year on fuel. And so if you save 10% of that, you're saving £5,000 a year. If they've got 1,000 vehicles, that's £5 million saved. So one little phone app can save a company a lot of money and can save a lot of carbon. And yet another example, the logistics modelling software that produced by our team at Heriot-Watt has been used in all kinds of applications. One really interesting one is that it was used to design a vaccine distribution program for Bangladesh. So Bangladesh, when its vaccine distribution, it's like the location of all the hubs and the warehouses and the vehicles and so on, was all designed by the software that our team has developed for logistics modelling. So that's another little example.